Hey everyone, Dave from Summit Racing back with you on yet another Friday live stream. This week we're going to talk valve spring tech with PAC Racing Springs. We have Matt here from PAC. Matt, how you doing today?
I'm doing wonderful. How are yourself?
I'm doing very well. I know you're hard at work at producing some product videos and technical videos, and for your customers to help guide them along the way. Kind of tell us what you've been up to today, and also give a little overview of PAC Racing Springs for our customers.
So what we've been up to today is we've gone over a couple of scenarios, when to change valve springs, just valve spring tech in general, difference between a series of springs that we offer, and, how to properly set up a spring based on your application. And unfortunately, there's no right or wrong way. It's really 100% application dependent.
Yeah. So we're going to kind of get into that today, Matt, a little bit, because there is a lot that goes into it, obviously. And I kind of want to touch on some of those things that kind of play off of one another. And I might be all over the map a little bit with this here, but, just in general, trying to lead our customers and your customers along the right path here. Talk about some of the things that do come into play when choosing a proper valve spring. Let's start a little bit with the camshaft style that you have. I know that hydraulics and mechanical, all the different types that come into play. Talk about how the camshaft fits in to choosing the right valve spring.
Well, obviously, like you said, you got different types of camshafts and different types of tappets. Ranging from a hydraulic flat tappet to a solid roller, and there's no one spring that goes across the board on them. We're ranging from anywhere from 90 pounds on the seat to upwards of 600 pounds on the seat in max effort applications. And there's no easy way, no one spring that fits every hydraulic and every solid application. So it's really, what are you doing with the engine? What's its purpose? Is it a street car? Is it a max effort quarter mile car? Is it an endurance application? All those come into play on picking a valve spring and the loads, the rates, and even, what series, 12, 13, even 15, and our hot rod series, the 19 series, and we also have a 1400 series that, covers the NHRA stock eliminator type of mostly solid flat tappet stuff. So it's there's no easy map on figuring out a valve spring. Unfortunately, every one of those aspects come into play.
Yeah, and of course, where does it live, and what RPM range is it living, and for how long? Those types of things too. You mentioned intended use, and that's where that kind of comes into play. But there's some other specs too that often get brought up: installed height, compressed height, coil bind, things like that. I guess first, as a 101, kind of give an overview of what those things are and how those also come into play.
Absolutely. So installed height is exactly how it sounds. It's the height of the spring installed with the valve closed. Open height is the height of the spring with the valve max open. And coil bind is where the spring is compressed solid. Now, how all those relate is, obviously, you need to make sure that your coil bind on the spring is going to be lower than the open height of the valve at max open. And installed height is really a relative number. And one very common misconception is you look at any valve spring catalog and they give you an installed height in a load. And that spring technically wasn't designed to be installed at that height. It's more a reference number. So you could have a spring that has a 2-inch installed height in the catalog, and it can be installed anywhere from 2/100, all the way down to 1/800, depending on, is the load right at that height, and is it going to handle the valve lift and maintain a proper coil line clearance?
Okay, yeah. So, I always hear installed height first, and that's obviously a part of this equation. Is there a right and wrong way? I mean, what's the correct way to go about measuring something like that? I feel like, there's some error among customers in doing that. So are there any tips for sort of, measuring the installed height as you go along?
Absolutely. Obviously, the most accurate way of measuring installed height is going to be with a height micrometer that physically goes between the cylinder head and the retainer. I've heard a lot of guys using snap gauges, calipers, all that. And there is a little bit of error. It's not exact. So realistically, a height micrometer is the best way to go, which is our T901, 902, 903, 904, depending on what type of engine it is. What it is, a Beehive valve spring, small diameter dual, big dual, triple. They all have their own place. So yeah, and what I would like to ensure is when you're measuring your installed height, if you measure it down to the bare head, you need to be sure to recognize that it's down to the bare head and notify us that it's to the bare head so that we can accommodate the valve spring seat in there so that we're not losing 60 thou that we're working with. And say we set a spring 60 thou from coil bind, thinking that there's a valve seat in there, and once we add that valve seat, we're really putting that spring in the bind, and that's going to cause all sorts of havoc, where you can break a retainer, pull a retainer through the locks, you can break the spring, bend push rods, bend brake rocker arms, and obviously pulling a retainer through is going to be your worst case scenario, where the valve is going to drop inside the engine and just cause all sorts of catastrophic damage.
Yeah, I'd imagine kind of the devil's in the detail when providing the information, especially you got math at play here, you got other components in play, and providing that type of information as you're buying the valve spring is ultimately seriously important. So how about lift and duration? How does that come into play on the camshafts, with the camshaft, and what valve springs that you choose?
Well, lift is the easy one to cover. Obviously, you need to make sure you have a valve spring to cover the total amount of lift. Duration's where it really gets tricky. I'm sure, as you know, you can have two camshafts with the same advertised duration numbers, but completely different acceleration ramps. And a 50 number is always helpful, but having a couple other reference numbers in there, which some camshaft manufacturers keep that a secret. So sometimes you can't always have that, but the faster the ramp rate usually requires a higher spring rate for the valve spring to keep up with the acceleration rates that valve is going to see.
Okay. I got a question in already from a customer. He wants to know what is acceptable variance from the manufacturer spec regarding installed height. Is there?
And as I said, there is no right or wrong installed height. It really comes down to the total package. If you're running 500 lift spec class with a solid roller, and you could have a spring that installs at 2-inch, but realistically it might not have enough load at 2-inch, and you need to install it at 1/900 to get the load. There's no right or wrong answer on installed height. It's really just a reference in the catalog. Easiest way to figure that out is working backwards, figuring out, okay, you have 500 lift, I can handle a 1/800 installed height. That means a 1/250 coil bind spring, giving us 50 thou clearance, is the tallest coil bind we can have. Now, obviously, I'm talking exaggerated numbers here, and they're very round, easy to handle numbers. But that's in regards, that's the easiest way to work, is working backwards from coil bind height, and then adding your lift and what you're able to handle for a total installed height.
Okay, that 50,000th clearance, is that typically what you recommend for coil bind, or?
No, my rule of thumb is 75 plus or minus 25 for most common applications.
Okay.
I've had guys set up as tight as 30 from bind, and I've had guys set up as far as 150 combined, depending on how heavy the valves are, how heavy the valve train is, how much we're lifting the valve, and what the total RPM range of that is. We have to account for loft, and it's almost impossible to calculate loft without a spintron, but based on all the applications that we've seen over the years and all the stuff that we've spun over the years, we kind of can get a general idea of what we're going to see. It's never going to be an exact, but we could generalize.
Okay. Well, let's get a little bit into your guys' product lines here a little bit. First, just tell us, materials and manufacture process. Just give us kind of an overview of benefits there of what you do and what you use.
Well, as far as materials go, every valve spring we do uses the same material. It is a premium grade super clean alloy that originally comes from Japan. And then as far as processing goes, that's a huge variation depending on the series of spring, versus a 19 to a 1300. That processing is going to vary greatly. But the main stuff is that they all go through a good amount of shot peening, and that helps with the residual stress, load loss, fatigue life that valve spring is going to see. And as we go up in tiers, we're going to see more processing done, whether that's even more shot peenings. It could be polishing, could be ID, OD chamfering, and our trademarked nano peening as well.
Okay, yeah, that's a lot of fancy stuff. I mean, it's almost like mystery stuff, the shot peening and all that. So let's talk a little bit about configurations as well. What about Beehive Springs, and why would somebody want to maybe choose that as an option?
Well, Beehive Springs are starting to really gain popularity, and the OEM has really helped that out a lot. A lot of people have been afraid of Beehive Springs throughout the years, but as we see more and more OEMs putting beehives on OEM applications, that's greatly helped out the general public's trust in a beehive that, okay, it's a single spring, it's not a dual, and they're seeing 200,000 and up miles on some of these engines with a single Beehive spring. So the great thing of a beehive is you have a lot less reciprocating mass. You have a much smaller retainer. We're taking so much weight of the valve train out, which that side of the valve train is by far the most critical side when it comes to weights and masses. And they have variable rates built into them, so you don't have a true linear rate, which helps with self-dampening of the coils and stability.
Okay. Just, for somebody maybe new to the topic, obviously the beehive kind of refers to the shape. So there's some weight advantages there too, right? I mean, you're kind of taking some weight off the material as well, or am I wrong?
Oh yeah. So like take for instance a small block Chevy single with a damper. Our steel retainer for a spring like that is roughly 19 grams. Our retainer for a small block Chevy Beehive spring is 10 grams. So we're talking almost 50% mass reduction in retainer alone, not to mention the mass reduction in the spring as well. So in general, you can see upwards of a 60% mass reduction and have very similar loads and very similar rates in between the two. So say with all things being equal, loads and rates, that beehive all of a sudden has a 60% advantage over that single with a damper, where you might be able to turn, another 1,000 RPM safely in that you would with that standard single spring.
So would you recommend the beehive then for certain applications, or can you not go wrong with it?
Certain applications, absolutely. Once you start getting to very high RPM ranges where, we're talking 8,000 and up, and depending on the lift, which is the biggest factor in how aggressive the camshaft is, you can phase a Beehive out really quick and see the need to go into a dual spring where it has the higher loads and the higher rates that the Beehive has. But for a lot of your daily driver, weekend warrior stuff, a Beehive fits, I'd say, the majority of those applications.
Okay. So over the years, I'd imagine, you've seen, the industry evolve and things evolve. Is that one of the big evolutions is going more toward Beehive, or what's some of the ways that you've seen things change on the valve spring manufacturing side?
Yeah, and as I mentioned, with the OEs doing Beehives, we're seeing more and more Beehives. And even in class racing, take, for instance, NHRA stock eliminator class. And I don't recall the exact year, so I can't quote that. They actually allowed these guys to start running a Beehive, and being able to go to that Beehive has increased that RPM ceiling that these engines are able to turn, and increased the severity, is the intensity, shall I say, that are ground into these camshafts. So they're making more power with less load than they were with a conventional spring now.
Okay. So let's talk. You mentioned the 1200, 1300 series. You have other series as well. Let's kind of go over each of those, where they kind of fit in on the product line, and just talk about some of the differences on those and where somebody would run each.
Absolutely. So we'll start out with the 1200 series, which is our standard catalog spring. Absolutely great in weekend warrior stuff. Even street cars it works great in. And usually what we reserve that to is, mid 700 lift range. Usually up to about 8,000 RPM is where we'll reserve that. Once you get past that threshold is usually where we'll, suggest upgrading to a 1300 series spring. You break that 800 lift range, and you're almost guaranteed you're going to need to go into a 1300, and especially breaking that 8,000 RPM range. And then another big factor is what are you doing with it? Is it a bracket car or is it a heads up car? Bracket's consistency. You're never gonna, well, I wouldn't say never. Your goal is to not hit the chip. Your goal is to shift at the same RPM every time. Whereas a heads up, if you're behind, you might, kind of stretch that RPM out and go into that range where you're really pushing things really hard. And same for same engine, bracket versus heads up. We might say, go to a 1300 series if you're running a heads up class, because you are going to occasionally push that envelope or occasionally hit that chip hard. And then we have even circle track stuff. There's 1200 on a mild circle track engine versus you talk a 410 sprint car engine where they might be running just to tick over 800 thou lift and 9,000 RPM. I wouldn't trust a 1200 on something like that. I would only recommend a 1300. And then we have the 1500, which is a nitrided spring, which is a different type of piece hardening. That's a whole different subject matter in itself. We could spend an hour just on that. And then we have a 1400, where I mentioned is stock illuminator. And what sets that apart from the 12 and 1300 is that is a very high stress spring. And it was made that way because, well, stock illuminator, you have to maintain the stock configuration. If your car came with a single spring, it has to maintain a single spring. You can't put a dual spring in there. So what we're doing is we're basically putting loads and rates that you would see in a dual spring into a single spring. And our catalog clearly says not for street use, because it's the stresses that we see in that spring are astronomical, and it's designed for running that quarter mile and shutting off, and that's it. And then we go to our 1900 series, which is for your hot rodders and your, moderate builds, where it's a very economical spring. Not to say it's not a high quality spring. It's definitely the lowest processing that we offer, but because we use the same material on every spring, we're not sacrificing the integrity, shall we say, in the 1900 series. It's just designed for your economical builds.
Okay. So yeah, each one of them sort of has its place in what you're doing, but it really comes down to, it sounds like the processing used, and in some cases, even the rates that are in the springs is what sets each series apart. Is that accurate?
Yep.
Okay. Yes. All right. Well, let's talk a little bit about, using or swapping out cams and how that might play. If you've got, if you're using, you're putting a new set of springs on some new heads, and you're using a hydraulic roller versus a flat tappet, you need to take the springs into consideration at that point, right? It can't be an afterthought.
Oh, absolutely. I mean, we all know that there's some hydraulic roller lifters out there that can handle 200 pounds on a seat and 500 pounds open. And you run a spring like that on a flat tappet, and most of us know what's going to happen immediately is those lobes are walking away. They're in your oil pan in the matter of shaving. So absolutely, the type of tappet we're using requires a different load and a different rate for the application. And there is no right or wrong answer for each of them. It really comes down to what you're doing and what you're building and what that engine's going to be used for.
Right. Yeah. So even if you've got a brand new set of heads with valve springs, you need to take a look at that cam that you're going to be running. LS swaps are huge. Junkyard LSs. You get yourself a junkyard LS. You need to look at the springs there too, real closely. Why would you recommend changing springs on something like that?
Well, for a couple $100, it's safe insurance. You don't know what those valve springs saw in that junkyard engine. You don't know how long that engine's been in the junkyard. You don't know if there's been any water introduced into that engine where it's going to cause rust on those valve springs, which is going to be your number one killer. If you have rust on a valve spring, it will fail. It's not a matter of if, it's a matter of when. So for a couple $100, it is just safe assurance. You can't go wrong.
So it's kind of speaking of that, when you're looking at valve springs, first I was going to ask about the life cycle of a typical valve spring, but also, if you're just going to, inspect a set of springs to decide if it's time to replace, what would you look for exactly in that situation?
So realistically, what you're looking for is load loss. And there's no right or wrong answer on the amount of load loss. It can vary. Some engines, once they see a 20-pound load loss, that's well beyond the life cycle, where 20 pounds on a max effort spring might be 2 runs worth of load loss, and they could see 40 to 60 pounds load loss before they need to be changed. But realistically, we like to see 10% load loss from new installed. You need to start thinking about it, and if you see 20%, you're basically know that you've hit the life span, and you really need to change them out just for insurance.
Okay.
Tagging a cylinder on a valve is never a fun day, and for a couple $100 to prevent that from happening, it's well worth the investment.
Okay. Yeah. We talked about checking, measuring loads. Any tips for that? I know you've got portable load testers and things like that you can use, but any tips on doing that accurately, or is it pretty straightforward?
Yeah. So consistency is key with an on-head tester. Number one key is consistency. You want to make sure that it is set up the same way every time. You're pulling on it at the same height. You're not pulling sideways. You're always pulling straight. And the biggest factor is testing the springs brand new. On head load testers are not known for being accurate, but they are known for consistency. So you could have a set of springs that install with 250 pounds, and say you're reading 225 pounds on your on-head load tester. It doesn't mean that the valve springs are at 225 pounds because they're brand new. We know they're at 250, especially if you check them on a bench tester. So what you want to do is write down that 225 pounds. That's your benchmark. That's what you're looking at. So when you get down to 200 pounds, you know you had a 25-pound loss. So you're really at 225 pounds. You should probably start thinking about changing them there because, well, we're at roughly a 20% load loss at that point.
Okay. Quick question from another viewer here. He wants to know, can you shim up the installed height to get the optimum open height for a style of spring when the cam lift doesn't quite get it there?
Absolutely. That's part of valve spring installation is knowing how much lift you have. So you definitely want to shim up to maintain an adequate coil bind clearance. And working backwards, the easiest way, measuring a coil bind on a spring, measuring a true coil bind on a spring, adding your coil bind clearance, whatever it may be, whatever we might recommend or whatever your engine builder might recommend, adding your lift to that, and then you're going to figure out where you want to install that, and adding or removing shim to get to that installed height based on that.
Okay. Yeah, that kind of segues into, the next thing I kind of wanted to cover was, how to properly install your springs. But before that, there's a proper way to handle new valve springs as well. Can you talk a little bit about that and how people should be handling their new valve springs?
Absolutely. Please don't handle your valve springs with your bare paws. We coat every valve spring in a rust preventative oil. And unfortunately, the oils on our fingers, on our hands, on our skin will counteract that rust preventative oil that we put on the valve springs. And we have actually had valve spring failures come back where we look at them under the microscope and we can actually see the fingerprints in rust on that valve spring. So it's critical to wear gloves when handling valve springs.
Okay. Yeah, I know. Say if you drop a valve spring, any issues with that as far as should you re-inspect it? Or, I've seen different things on that as well. So,
well, if this gives any insight, in our manufacturing process, no matter where the valve spring is in manufacturing, if it's dropped on the floor, it's pitched, it's done, it's garbage. So if you can figure that, regardless, even if it's been before it's been peened, before it's been polished, if it's pitched, you can safe to say that if you drop a finished valve spring on your floor, probably don't want to run it anymore because there's a good chance that there's a dent or a scratch on that surface, and it will cause a surface-initiated failure.
So better safe than sorry in those situations, for sure. Yeah.
And we have we have top-notch metallurgists, probably the best in the industry, in the best lab in the industry, where we could see that mark on the valve spring after a failure.
Okay.
Just a heads up.
So talk about the installation process a little bit too. You have any tips on that? We kind of covered it a little bit, in bits and pieces earlier in the video, but just some tips maybe you can provide our customers for proper install of valve springs.
Absolutely. As stated, wear gloves always, and no screwdrivers in the process. You don't want any hardened tools with edges that you can, lose your grip and slide and hit a valve spring. Use a proper valve spring compressing tool. We've all seen the ones with the claws that come underneath the coil and pull them up. I'd advise against something like that. I prefer something that's mounted to a rocker pedestal or a rocker stand that comes down and pushes the valve spring down. That's really your safest way. And it's your most safest way, one, in not damaging the valve spring, and two, I'm sure a lot of us change struts out there and seen them clamshell strut changers. You're hiding behind a piece of wood holding on to those. So, I mean, if a strut can slip out, a valve spring can slip out.
Right. Yep. Now, I'm just going to ask, I think you've kind of covered some of the common install mistakes, kind of circling way back to the beginning here a little bit on just making sure we get the right valve springs into people's hands. Any common mistakes? What's the most common mistakes you're seeing when people sort of choose their valve springs without getting the right help?
So probably the most common mistake I see is they'll look at a catalog and just look at the installed heights that we list in the catalog. And that's really 100% reference numbers. So you got a 2-inch installed height. They're looking at springs that list 2-inch installed height in the catalog, not realizing that maybe something that lists 1/900 installed height or even a 2/100 installed height might be the proper spring for the catalog or proper spring for the application. And that's one of the reasons that we include the load charts is that if your camshaft manufacturer recommends 300 pounds on the seat and you require a 2-inch installed height based on your lift numbers and coil bind numbers, you can just look at our load charts at 2-inch and run across that load chart and find that 350 pounds where it matches up. And then based on that, then you figure out, okay, well, that spring coil bind low enough to handle the lift and so on and so forth. It's a matching game. You start at step 1 to get to step 5, and sometimes you find a spring that matches at step 1, but it doesn't at step 2, and you got to go to the next one.
Okay, yeah. So installed height, just a reference. There's more to it, and you guys provide all extra information to make the right choice there.
Absolutely.
What about the accessories, components that go along with your valve springs? Let's talk about what you guys have to offer and any recommendations there or pitfalls to avoid when adding things like retainers, locks, and things like that.
Well, I mean, naturally, I'm going to say you should be using our products with our springs. Not always necessarily true. A lot of times, titanium retainers are not cheap, and if you already have a set of titanium retainers, I don't blame you for wanting to reuse them. I would too, to be honest with you. You just got to make sure you get the measurements on those retainers and have the proper clearance with the new spring you pick. But we offer full line spring seats, spring shims, valve locks, both steel and titanium, and valve retainers and chromoly. We have 2 different grades of titanium, and then we have the premium tool steel. So we offer a full range for every application.
And you'll help match them up, obviously, with the
100%. I mean, we're out to help the end user, regardless what components they are.
Another quick question for our viewers. You offer the same installed height and the same style spring with different seat pressures. What determines the needed seat pressure? I mean,
it really, a lot of it depends on the intensity of the camshaft, what rocker arms you're using, especially when it comes to the LS industry. All rocker arms, as we know, are not created equally. Some require more loads than others. And what lifters we're running. Are we running a standard OEM lifter? Are we running a high-end premium race grade hydraulic lifter? And masses in general.
Okay. Yeah, appreciate the customer questions here. I guess kind of wrapping things up, circling back to the beginning a little bit. So when the customer is ready for a new set of valve springs, what information just to sum it up, should they have at the ready for whoever's helping them out in determining that spring that they need?
So what we'd like to know is what their installed height is.
Okay.
And by that, we like to know with the spring seat, or if without the spring seat, that needs to be aware. But no shims in there. We want to know the max installed height we're dealing with. Camshaft specs. It's always nice to know what the camshaft manufacturer recommends for spring specs, because obviously they know their camshafts better than we do. As we know our valve springs better than a camshaft, the manufacturers know our valve springs. Everybody specializes in their niche, so any information on that, we'd like to know what size valve stem diameter and what type of groove, so that if we're pairing up our locks, we can properly set them up with the proper locks. And then if they want to run a titanium or steel retainer, if they already have one, I need to know the different step diameters of that retainer to ensure whatever spring I'm choosing is going to fit that retainer properly and it not be too tight or too loose. And valve guide diameter. So if you don't have spring seats, I need to know the valve guide diameter to make sure I'm giving you the proper spring seat for that valve guide.
Okay. Yeah, great information to get people on the right track, at least. Help you guys, more efficiently get them set up with the right set of valve springs. Matt, certainly appreciate the knowledge here today and the time you've given us. Really looking forward to seeing the videos that you guys are working on, because I know that you're directly addressing things you see come up and questions and different technical, like I say, questions that people may have or mistakes that maybe they've made. So looking forward to seeing those as well. I'm sure that we'll be sharing those probably on all cylinders here and getting the word out. So again, thanks so much for the knowledge and time, and hope you have a good weekend.
Absolutely, Dave. Thank you.
And thanks to everybody out here watching. Once again, with another Friday live stream with Summit Racing, and hope everybody has a great weekend. See you next time.